Thank you for inviting me to talk today, and I'm very impressed with the size of the group. It's daunting on a number of fronts. One is following Jeff and his group with what they're doing, and somebody who's been handing out that sort of book is very impressive. Driving into Sydney to get here by 9, very impressive. And I guess following all of the speakers, I can find some common lessons and themes through all of them. And so I suppose in many ways this might be just a summary of what's gone before. That's actually Tomago wetlands. Add water, get birds is the lesson there. I'm going to be talking about saltmarsh recovery in the Hunter Estuary. And so chestnut teal, black-winged stilts coming into the salt marsh around our place, and thank you to Alan Fries for the photos. They're fantastic. I'd like to just acknowledge and pay my respect to the Awabakal and the Worimi peoples, who Worimi to the north and Awabakal to the south, but mixed in the Hunter Estuary together. They're everything they needed to support their communities and still work with the project today. In the Hunter Estuary, we've got an internationally significant port, mostly for coal, and then an internationally significant wetland. So there are different views, looking at it from east to west, west to east, and we're trying to bring that together so that the Hunter Estuary, Newcastle in particular, can celebrate both. Bartail Godwit, the international significance of the wetlands around Kooragang in the Hunter Estuary are due to the migratory shorebirds. There's around 30 species that come. There were probably about 16,000 of them back in the 70s, and now they reduced to about 4,000. But now with the bulk of the projects, I'll actually tell you the final first, so in case anybody falls asleep or has to go. We probably have more as a result of the body of work going on with saltmarsh recovery and opening up floodgates. We probably have as many sharp-tailed sandpipers as we used to have for all species combined. And so the opening up of Hexham, opening up of Tomago, and the saltmarsh work on Ash Island has had a measured effect as measured by the Hunter Bird Observers Club. But remarkable birds, so this has been satellite tracked to go in one flight from Alaska to New Zealand, over 11,000 kilometers in one go. They breed up in the Arctic Circle and they come down to Australia to relax, put on fat, enough fat to get themselves up to the Arctic to breed again. So we have to look after them while they're in their summering grounds here. So this is the Hunter Estuary. The tidal extent goes to Seaham Weir on the Williams River, Goswick on the Patterson, Oakhampton on the Hunter. I'm talking about the lower Hunter Estuary, which is where the saltwater and the freshwater mix, and we have a brackish system, saline system, whereas up on the upper reaches of the estuary, the freshwater just there's still a tidal effect, but the saltwater just pushes that freshwater back and forth, so you have a freshwater system in the upper estuary, but you have that saline system in the lower estuary. This is the area. It's a bit like a theme park for saltmarsh on the western part of Kooragang Island. We have about every permutation of saltmarsh circumstance. For those that deal in the resilience literature, they're always talking about tipping points. Hunter Estuary has already gone through a tipping point. There is some evidence that before the flood, the valley floor was cleared of its forest, that there were leather jackets being caught in the fisheries catch. They need seagrass. I'm going to mention seagrass. I know, but now they're not. And so there's some evidence that there used to be some seagrass in the Hunter Estuary, but there's no seagrass now. And it's unlikely because of the turbidity of the water from clearing the flood plain and the valley floor that we'll ever regain a clear water column again enough to get seagrass back. So we've sort of gone to a turbid water, and that's probably where it will stay, and just work with that. Coastal saltmarsh. Of course, it's an endangered ecological, beautiful in its own right and valuable in its own right. Fisheries nursery habitat, and there's some evidence fish preferentially feed up on the saltmarsh, and it pumps that crab larvae into the system, so it's really important for food. the shorebird roost, of course, and then it has a lot of physical buffering capacities for flooding and erosion control. Sarcocornea, you've heard these before. We have Triglocon striata, Sporobolus virginicus, all sorts of circumstances. This is a park-like Svoboda-dominated salt marsh underneath mangroves. So they're not mutually exclusive necessarily. Now, and I'll also tell you, this is the other final probably lesson we've learned, is that we've generally let the salt marsh naturally regenerate, but the one element of a system, if you're not too concerned about the height, and adding patches, is that the Kraussii doesn't normally come in on its own. And if you need a patch of Kraussii, Juncus Kraussii, you should plant it and make sure that you don't get Juncus acutus. I have seen that down at Lake Macquarie. People have spent some effort planting Juncus acutus. The main thing is if you touch it, it'll go through your hand, whereas the Kraussii is a little bit prickly. This is the area where we're working. It actually looks like the Southern Cross. So I actually changed those to stars. I had originally had them as circles. So there's the Southern Cross of salt marsh examples on the western end of Kooragang. Hexham, Newcastle, Hunter Wetlands National Park, Hexham Swamp, about 1,000 hectares there. This is about 700 hectares, about 600 hectares up at Tomago Wetlands. So we've got this beautiful band of ecological unit across the western edge of Newcastle. Tomago, again, this is just increasing tidal flushing and waiting for them to come back. So we had some evidence from the 70s that they were there, and so we just provided the water for them to come back. This is some disturbance. So I was interested to hear about the roughness, improving the speed with which the native salt marsh species could colonize. And I'm thinking that the disturbance from cattle, I mean, it's not going to be recommended, but maybe it, in that circumstance, helped this recover, because this recovered within a year of going through the king tide cycle, was revegetated, mostly with a Sarcocornea-dominated landscape. Another area increased the tidal flushing, which was replacing a pipe culvert with a bridge, took the disturbance off, which was cattle, and this actually self-designed into more of a mosaic. So that was that first photograph where we have some Triglocon, Sarcocornea, and Sporobolus in more of a mosaic circumstance. More into the excavation or the constructed salt marsh. This is over at Stockton Sandspit, probably one of the best roost sites for migratory shorebirds. We just had Welcome Shorebirds community event on Sunday, and we had over 200 people there, and just trying to get that to be more of a mainstream, not just the domain of bird observers or conservationists, but trying to get it into the Newcastle's psychology, that it's just as interesting as Blackbutt, the beaches, the historic buildings, and Stockton Sandspit. So this lagoon was just filled with beautiful shorebirds on Sunday, and that's a completely constructed pad of sand that was constructed during the bridge building, and then what was degraded. That's where they had the thousands of shorebirds after it was constructed. Then it was degraded, so scraped it off, formed the lagoon, let the salt marsh come back, self-design. And also the one thing that made the big difference there was to remove a fringing set of mangroves along the edge, and that actually brought it into its own, and it boosted it to thousands, went from tens to maybe 100 at most, to thousands of shorebirds using it within the first season. Now, this is an interesting exercise. This was done, it cost about $10,000 to do 30 meters by 100 meters laser leveled, and I think this goes back to the fact that you don't want to laser level it. Leaving it rough to start with is actually a good thing for that natural regeneration. And this is after quite a few years. This is actually written up as part of Peter Nelson's PhD thesis. He also worked up at Happany. But the results of this experiment, we did different treatments in strips, and then we had to have a uniform tide going across that, which is why it had to be so level. But I think the leveling in its own right has made it difficult or not as successful to self-design as it might over time. But the results from this was that if you replace topsoil, if you scrape it off, over-excavate one section, replace the topsoil, that strip was the one that did the best. However, there's what we found in practicality, to extend that from a 30 meter by 100 meter experimental plot to a 10 hectare created bit of salt marsh was impractical. And so what we trialed here was to just do the contours to get the water flowing. So at the bottom we would have a 1.9 tide. At the most, the middle would get a 2-point tide, and at the northern end we'd get a 2 meter tide. So we're hedging our bets a little bit. And within a couple of years, it went from a baggy paddock of exotic pasture grasses, which wasn't really good habitat for anything. Excavated it off, but in that excavation there was really no practical way that we could have over-excavated and then replaced the topsoil. So we just excavated to the levels that we were given, and we just visited it once. So if you just excavate it, work your way out from the center, because if you went in again over that excavated, you just get everything bogged. You just physically couldn't do it with the machinery. Because once you break that surface, it's just too soft to run the machines over again. So we just left it with we didn't go into the acid sulfate zone, so we had confirming the null hypothesis, unfortunately for the honors student, which was not very interesting for him, but great for us. So we didn't have any difference in the acidity of the soil or the acidity of the groundwater. And we went about no more than 70 centimeters down, got this mosaic of salt marsh just with a self-designing process. But one thing that doesn't show up on its own is, or without some encouragement, is the Juncus kraussii patches or fringes that sometimes happen. Now I'm assured that that's a good thing that he's doing. So this is involving the community, and the good thing about Juncus acutus, not Juncus acutus, Juncus kraussii, is that it fills the same niche as Juncus acutus. So you take the Juncus out, and then if you can just gently take it out or take it out by hand, you can replace those niches with Juncus kraussii. And that is something we found that school groups can do, because we have a place where we've grown Juncus kraussii, and so we can take bundles of it, separate them out, and then they can just be put directly into the place where you're trying to encourage it after taking out the Juncus acutus. So it's a very immediate, they can get into getting those trophy Juncus acutus out, and they're usually pretty proud of themselves, and then they can put the native equivalent back in. I'm always a little bit uncertain talking about getting rid of the exotics, those ones that come from other countries, and then putting the natives back in, because I'm thinking my own personal circumstance. But never mind. The Juncus kraussii edge. So instead of mowing right up to the edge of a salt marsh, a lot of the upper edges of salt marsh have some sort of development along them. You can have this beautiful filtering fringe. It also catches mangrove propagules if it happens to be where the water is flowing in, and so they can get caught up in the kraussii and maybe not colonize the salt marsh behind as quickly, we found. There's a fellow in another circumstance where we're planting the top of the riparian zone with woodland floodplain species, and then planting the kraussii just in this intertidal zone. So that's a very narrow strip. So instead of making the patches of kraussii, say in certain areas where there's Juncus acutus before, this is more of just in that very narrow intertidal area with rock fillets. And again, the rock fillets are a very interesting exercise because they capture salt marsh and mangroves, and we've got all sorts of different permutations with maybe just centimeters difference in their elevation. The Hunter Estuary has gone through huge amounts of modification. So the original vision was 2,600 hectares of industrial area, bigger than South Botany industrial area. But the good people of Stockton complained when stage 1 went in back in the 70s, and so we only have about a third of the island, which is now the coal loaders, and about 2/3 went into, well, about a third went into conservation, and then a third went into, we'll wait and do it later. So when we started the project on Ash Island, it was actually still zoned general industrial. And now, in 2010, it's now part of the Hunter Wetlands National Park. So it's been a great effort on a number of people, on part of a number of people, to get to that result. And that's probably another daunting thing, is that there's so many people that have been involved with this project that I'm just mindful that I'm speaking on behalf of all of them in the general community. I was interested in Justin's talk that he had 240 species. I've got about 240 species listed in a document we found in the Mitchell Library when we started the project, called Botany of Ash Island, 1862. And it was a list, a phylogenetic order, scientific name, of all the species on Ash Island by Helena Scott before it was cleared for farming in the late 1800s and the early 50s. No project comes along with that. And so we were handed this within a year of starting the project back in 1993, and we've underpinned the restoration of Ash Island based on that, but with all the modification, we've had to take in a lot of other constraints into consideration. I guess when I talk about Saltmarsh, I also have to talk about mangroves, and I also talk about what happens in the just above the Saltmarsh. So I was interested in that promotional photograph, and I think I must have been talking about how much higher it has to be the ridge line on Ash Island, and I think it's probably about that much is the high ground. You know you've been there too long when you see that ridge over there where you can plant the floodplain forest, and it looks like it's been laser leveled, and it's just alluvial deltaic island, so the river has done it for us over the years. But what's interesting is just having that resource from the Scott sisters who lived on the island as the first land grant owners, but just such good luck that they loved the natural area. So they had a little bit of agriculture up on Scott's Point, famous oranges around the colony, but then the rest they just left, but they also studied it and documented it. So very handy to have all of that on offer. But I was just interested to see the depiction of Ash Island riparian by Mertens looking a lot like that, which is our plantings. And so it's good to see that we're at least getting that structure back onto the riverbank. I guess the two lessons that would come from this is that we're managing the buffers of the Saltmarsh. So if you have the luxury of, managing the hydrology to get the Saltmarsh sort of self-designing, and you're happy with that, unless you've got other specific criteria that you have to meet, and you don't have the luxury of time or space, and you have to have a certain thing within a 10 square meter area within 6 months. If you have a little bit of time and a bit of space, and you can let the bulk of the Saltmarsh self-design, keeping on Juncus acutus and maybe the mangrove encroachment, probably the part that we've found that has to be entered into the system is the Juncus crasii element, and also we've had to plant, because we were just left with kikuyu paddock, have to plant that riparian floodplain forest, the riparian woodland, riparian rainforest that was pretty profoundly cleared. We had lost about 75% of the species, but had just enough to work on to put a corridor of that red cedar forest back onto the landscape to complement the intertidal zones. One of our mantras is the only constant in an estuary is change. And so you have to be happy with change. The only thing I think you really can't do is have a snapshot view of even the ephemeral rainwater-fed swales that are interspersed amongst the tidal areas. They go through, we've got them documented now, go through about a decadal cycle of a wetting and drying cycle. So you can look at them one time, they'll be saltier than seawater. You'll look at them another time and they'll be fresh and beautiful. And then when somebody goes and looks at them again and they're saltier than seawater, they think something's wrong, but that's actually their natural variation. And so we've got that well documented now. But I think managing expectations is a really big part of managing estuaries. And also actually I was just going to say here, this top one is under a low sea level rise scenario. The dark is shifting what is now probably floodplain forest, riparian woodland to wetland. Under a high sea level rise scenario, that whole area goes to more open water. We can get very concerned about our regeneration or recovering salt marsh. Meanwhile, in another room, there's somebody that sells 400 hectares of potential salt marsh migration zone, without anybody knowing about it. So unless we keep an eye on the planning and the legislative underpinning of other things that are going on around the government circles, while we're very busy on one patch, you can lose hundreds of hectares in one go with one decision if somebody's not there to show how we can have it all. So it's not necessarily salt marsh or development, but if we are there, or if at least somebody from this group is there and they know how to present it, they can bring some sensibility into that discussion and show before it's sold off and promises are made, we can show how we can allow the salt marsh some buffer areas to migrate into with sea level rise and have excellent development areas where they make sense. So that's really been the big challenge in the Hunter Estuary over the years. I couldn't agree more with Jeff's assessment that the more you work with these systems, the more questions come up. So if anybody wants to do a PhD on physical factors underpinning different types of salt marsh and their biological implications, I'm happy to be on a candidate's committee. I think I'm maybe past actually doing the PhD myself, but I'm happy to help, and I'm happy to provide a few study area ideas for them. This is one of those areas that we saw some areas that were dominated by Sarcocornia. This is one dominated by Spirobolus. So what causes that difference, and what are the biological implications? So, and I'm sure you have some questions as well. So I'll leave it at that.